Okay, we're going to do the 2005 question number 1 on the AP Calculus exam from Form B. So it says, let f and g be the functions given by f of x equals 1 minus sine of 2x, it's here, or sorry, 1 plus sine of 2x, and g of x equals e raised to the x over 2. Let R be the shaded region in the first quadrant, enclosed by the graphs of f and g as shown in the figure above. So part A says find the area of R. So if I'm finding the area of R, I need to know that I'm going from 0 to whatever this x value is here. So go ahead and put those in as y1 and y2 on your calculator. We're going to find where they intersect. Okay, so when I hit intersect, I'm going to go along the first curve, hit enter, go along the second curve, hit enter where I think they intersect, hit guess. Okay, so when I do that, I get the point 1.1356 and so on, comma, 1.764 and so on. Okay, I want to save those in my calculator, so do second quit and hit the x value, enter. When you hit X and enter, you get 1.135692535. All right, you're going to store that. So let's store as C and D. So hit store, which is STO. And I'm going to do alpha C for the first one. And then I also want to store the Y value. So actually, if you do alpha Y right now, it pulls up what you found for the intersection point. So alpha y, it gives 1.764462776. I'm going to now store that as D. Okay, and then write that on your test. So write that you stored that one as C and this one as D. So now anytime you refer to those, you can just write C and D. Okay, so part A, it says find the area of R. So my area is going to go from 0 to that x value, which is C. And it's going to be the top curve minus the bottom curve. So go ahead and write f of x minus g of x. Because if you made an error when you were writing it down, you would have missed a point. So at least you have that written down. And now if you really like to write it, you can write that down. You don't have to though, it's kind of just wasting time. Okay, and since I have these saved as y1 and y2 in my calculator, so that was y1 and this one's y2, I'm going to use that to my advantage because now when I set it up on my calculator, I'm going to hit Math 9, which is finite integration. I'm going to have y1 minus y2, and my x values go from 0 to alpha c. So when I input that, I get 0.429. So your answer is 0.429. Oops. Okay, so let's do part B. Pause real quick. Part B says, find the volume of the solid generated when R is revolved around the x-axis. So when I go around the x-axis, so it's right here, I always remember with the disk and washer method around the x-axis means with respect to x, so I'm going to have all x's in my problem. I go to my outer radius and my inner radius. That's capital R and this is little r. So I need to find what those are. So capital R, my outer radius. I always think of it kind of like the area, top minus the bottom. So it was just f of x minus 0, so it's just f of x. Inner radius is just your g of x. So when I set it up, my volume is pi times outer radius squared minus pi times inner radius squared, and then I integrate. It's like you're adding up all of those circular cross sections, all of the washers. Remember the washer? It looks like that. You can do in your videos. Yeah. Okay, so outer radius squared, so f of x squared minus g of x squared dx. And your x values still go from 0 to what we called c before. Okay, so if you didn't write it with f of x and g of x, it'd be 0 to c. F of x is 1 plus sine of 2x squared minus g of x e to the x over 2 squared dx. Okay, so like I said, I would probably just use my Math 9, leave that as y1, this one is y2. So when you put that in, you get 4.266 or 4.267 if you round. Okay, so that's your answer. Okay, and the last one, it says the region R is the base of a solid. Oops. For the solid, the cross sections perpendicular to the x-axis are semicircles with diameters extending from f of x to g of x. So it's like I have a little semicircle coming off of each of these cross sections. So I'm going to add up the area of all of these semicircles. Okay, so the area of a semicircle is pi r squared divided by 2, so 1/2 pi r squared. So we're going to use that. Your radius, though, is kind of hard to find because this is your diameter here. So we actually need to find what the radius is. So let's go to the next page here. So your radius is f of x minus g of x divided by 2, because that was the diameter, f of x minus g of x. All right, so my area of each cross section is pi times my radius squared, and then times 1/2. Okay, so let's kind of clean that up a little bit. You're going to have pi. When you square this, you're going to have 2 squared on the bottom times another 2. So I'll have 8 on the bottom, and then I have f of x minus g of x squared. So that's how I'm going to write my volume. It's going to be pi over 8 on the outside. I'm adding up all of these areas, so I'm doing the summation, so I'm integrating. And my x value still goes from 0 to c. Okay, so this is saved as y1, this is saved as y2. So when you plug all of that in, you get 0.077 or 0.078. Okay, so let's look at where all of our points were on this problem. Okay, so first of all, we got 1 point for having the correct limits in A, B, or C. So that's just having from 0 to what we called C. So 1.13569. For part A, we get 1 point for setting it up correctly, 1 point for the answer. Part B, 2 points for setting it up correctly, and 1 point for your answer. And part C, 2 points for setting it up correctly, 1 point for the answer. Okay, so we got all 9 points on that.